Hey everyone, welcome back to Urban Informatics and Modeling, and this is Josh, and today I'll be covering about Pedcatch. So Pedcatch is a pedestrian catchment, so it's to calculate how much areas, how much ground that someone covers when they are walking in the X amount of minute. So it's really useful in urban settings. For example, how much can a person, how much area can a person cover when they walk 15 minutes, for example, from a certain point in a city. So that's sort of showing the information of accessibility and walkability. And there are several ways to do it. So the first one here that I'm showing you right now is using Grasshopper. So Grasshopper has a possibility and capability to do a Pedcatch, but as you can see, it's a very complex algorithm, very complex strings and methods. And this is based from my studio. From my studio, my tutor has provided this as a design challenge. I'll just show you that it is possible to do the Pedcatch in Grasshopper and Rhino. And if you ask why would you do that, because sometimes if you want to export it directly into lines, you can do it and you can do it from Rhino and export it into Illustrator directly. Because if you do it from the website and you want to do it in Illustrator, you have several steps that you need to go through. So right now we're not going to go through the Rhino one, and we're going to go through the Pedcatch one because that requires lesser skill from than this one. This one you need a lot of practice, and this one you need a lot of things that needs to be considered before jumping into Grasshopper and Rhino. And this is very complex. I'm not going to show you this one, so we can close it for today. Close it. Not going to save that. So right now we are in pedestriancatch.com, which is pedcatch.com. This has been covered in the previous exercise, but I want to show you how we do it in our project. So again, go to Dandenong, since that's our project. Dandenong Vic. And what I did firstly is just to change this to OpenStreetMap so it's not confusing. And control to scroll to zoom. So as the previous exercise, the first dot is here, so that's sort of like the central of the area where the people, the agents, could disperse and creates like a catchment. But in this project, we specifically want to focus on 3 different locations, because those locations are the most important area for someone to access. And this catchment defines which area that we need to choose for our final project. So the first area is the station, of course, because in dealing with public housing and in dealing with homelessness, public transportation is really important, because they cannot afford to have a private car, and even though if they can, they will still need a house that has a garage, and that's going to add more value to the land. So to avoid that, we want to make sure that they have really good access to public transport, and in this case it's Dandenong station. So, and here we set the limits to gradient 1 to 14, which is the normal gradient for ramps, and the time we can adjust it to 15 minutes, which is within the amount of bearable walking distance and bearable walking time. So start the scenario. Okay, so now the solution is finished, and what I forgot to mention is to change this to offset buffer 50 meter, because that's sort of like giving a more realistic and more accurate simulation to show the extent of a person that can go further than this amount, because sometimes people can walk faster than this speed at some certain point, and they can get slower. So the buffer will be good just to estimate and give you more accurate numbers of the pedestrian catchment. So after you've received the whole simulation just like that, and the result, it shows the area of coverage, and with that exercise has been covered before, so just download it in KML scenario, and we can export this to Mapbox using QGIS. Okay, so it's already downloaded here, so it's as .kml, and we can edit this later in QGIS. But right now I want to show you another way to do it in here, because I mentioned earlier about 3 areas. Now the way I did it for this project is that to download the area one by one and upload it to QGIS, edit it in QGIS and upload it to Mapbox, so it's in a separate file and it's a separate entity. But I want to show you can do like a single simulation in 3 different areas. In 3 different areas. I just accidentally zoom in like that. So zoom back in. So the second and third one is the access to groceries, in which case is Dandenong Market and Dandenong Plaza. So here in this drop down button here, okay, so you can see here that this is the result of the simulation. It's just a very different kind of result from the previous one. It takes longer because you need to calculate it from 3 different sites, but this shows the pedestrian catchment exactly and simultaneously from 3 different sites. So you can do that, and then you can download the KML scenario and edit it in QGIS. Make sure that the orientation and the projection is in pseudo Mercator WGS84, which is the 1984, the old one, for it to be uploaded into Mapbox. So that exercise, and that has been covered in the previous exercise. So I'm not going to do that again, but I'm going to show you directly the impact of this information within this project. Okay, so before we're going to Mapbox and upload it to Mapbox, I'm just going to show you how to export it to AI Illustrator. It's quite tricky and it needs a little bit of further step rather than just uploading it and opening up in Illustrator. So in here you can see that I've already done some adjustment to the plan and Pedcatch the KML file. So what you want to do is just to export this as DXF file. So in DXF file, that can be read by Illustrator as well, but I will show you that this is not the case for this instance, because there is a coordinate system that Illustrator doesn't have, and only AutoCAD has it. So you need to export it to AutoCAD first, plot it, print it as a PDF, and then you can input it to Illustrator. So I'll just show you how it works now. And make sure that CRS is correct. At the moment, the CRS is all over the place because I've tried to use it specifically for Mapbox, so that's why I'm not going to change anything. But preferably, you want to use GDA 94 MGA Zone 55 for Melbourne. So you can see here there's a geocentric datum of Australia 1994. So that's the coordinate data, CRS data, that you want to choose for Melbourne. So change the file name. So as you can see here, I've already done this process before. Save the file, override it, and then open the AutoCAD drawing. Now when opening an AutoCAD drawing, you must take notice that sometimes it gets an error and it doesn't really working. So you need to be careful, and then you just need some patience in opening it. Just like so. In a minute, there's going to be alert like so. Just say no, zoom out, and as you can see here, it shows in hatches. So you can make the polyline. You can make each polyline. So the way you do that is just to select each hatch, recreate polyline, and that's it. But I want to show. But if you want to just export the outer part to make sure that there's no layering that's going to be seen in Mapbox later on, what you want to do is just to isolate this by hiding this object, delete the rest, and end object isolation, and there you go. You currently have the largest catchment shown in hatch. And then what you want to do is just to recreate polyline, delete the hatch, and you have this part here. So what you want to do is just to make a save as, just to be sure. And you can do it in DWG right now, and that's much safer because you can have full editability and it's fully functional as an AutoCAD drawing at this moment. So you can just plot it. Oops. Yep, there you go. So it's not working because the alert in the initial part where it says that the file is being opened is currently working, so I can't really do anything. So the way you do it is just to close it, save it, yes, close it, and open it again. So currently that's the DW file, and then after opening it, so you can see here it's the same as before. And one thing that you have to note here is that it's currently skewed because my projection is not really correct. As I said before, the QGIS I've already set it up for Mapbox, that's why it's currently skewed. So if you want to do it in Mapbox and Illustrator, I recommend that you do 2 separate files. So after that, you can just plot it like so, just anywhere, because you don't really need the size in Illustrator. You just need it to be quite diagrammatic, and save it as Adobe PDF. Doesn't really need to. And then everything's done. Make sure you preview it first. Now with the student version, that watermark is going to be visible, but you can delete that in Illustrator. So just press OK. As you can see, I've done this process before, and that is ready to be inserted into Mapbox, into Illustrator. So you can see here, I just input the PDF file, delete those, delete those, delete those, and delete those. So there you have it. Right now you have the full pedestrian catchment in Illustrator. Yep, in Illustrator. So at this moment, you can see that some of the lines are not joined, and that's very easy. So you can just join them, and you can have maximum editability in here. For example, changing it to hatch like that, changing the colors, like for example, getting with red. At this moment, I just did it in the image is in the grayscale, but of course you can change that. Of course you can change that in later on. So that's how you do it in exporting from Pedcatch to Illustrator. It has a lot of steps, and you need to be very detailed in every of those steps, but this is for maximum editability if you want to do it in Illustrator. And the next part that I want to show you is in Mapbox. Okay, so you can see here that I'm already in Mapbox, and I've already uploaded my KML files, and this has just downloaded the three point files. So the benefit of doing one by one is that you can edit it fully in Mapbox, because if you download the 3 dots at the same time, like the ones that we did just now, you cannot have different colors like this, and it's going to have a very different result. So I still recommend to do it one by one, because firstly in Pedcatch that's going to be much lighter and it's going to be much quicker than doing the 3 points at the same time, and you can have a maximum editability in Mapbox. So after uploading it to Mapbox, the tile set, so you just, as usual, put it as a fill and choose a color, and try to change the opacity, because if you don't, this will happen. So it's showing the solid colors and doesn't see the layers beneath it. So the way Pedcatch exported into Mapbox is that they have different layers, and the layers indicates each milestones of an area that the agent go through. So you can see here there are several lines that denotes several layers and several milestones, and I will change this back to 0.1, and from there you can have like a depth and layers upon layers of the Pedcatch. So when you try to superimpose 3 different layers, this is the result that you will have. So what's the benefit of looking at this is to see which side is the best for any access. So from here you can actually turn it off, on and off, just to see which side is the best. So what I did here is that to firstly have the Pedcatch as a fill and then add the border later on. So just copy and paste and change the type to lines from fill, because when you put the Pedcatch data, the .kml data to Mapbox, it's going to have two different data type. The first one is line type and second one is fill type, which also can be used as a 3D extrusion, but we're not going to do that. So hide all of the stuff that you don't need, and you can see that this is a single data showing the pedestrian catchment from the analog station, and you can see this amount of sites that can be covered. So the next part here is to see the plaza, and this is the area that has been covered by in the plaza for 15 minutes walk. And lastly, which is this one here, that from the Dandenong market, it's the same 15 minutes walk, and it shows the coverage also. So you can see here there are several sites that covers 3 of them. There are several sites that also only covers 2, and there are several sites that only covers 1, or there is more than one site that covers 0. So you can see that differentiating Pedcatch shows layers upon layers, and superimposition shows the complexity and depthness to the information that you can receive. So I still recommend you to do it one by one rather than 3 at the same time, just to see this kind of information that doesn't exist when you do it at the same time. So this information that you have now, that is helpful when in choosing the site, and that is why we choose site number 2, because if you see from the previous one, if we go back, you can see that site number 2, site number 8, 5, 9, and 3 all is covered by in this pedestrian catchment, but there is another criteria that defines site number 2 is the best, which is land pricing, and I'm not going to talk about it right now because that has already been covered in the video presentation. So if you look back and show the rest of the pedestrian catchment, so you can see that from Dandenong Plaza, of course, it's going to cover, and lastly from the station it is also going to cover. So this is the intersection, this is an intersection, that is an intersection, and that is an intersection. So site 5, 8, 9, and 2 is the intersection of the pedestrian catchment, and that's showing the information that these 4 places are accessible and walkable for these 3 important areas. So that's the sort of information that you can extract from Pedcatch, and by detailing it in Mapbox and by doing it one by one in Pedcatch. And that is all for today, and I'll see you in the next one.